Good day, folks. Welcome to my YouTube channel. This is the Western Cape MCED trial in 2021 on electric circuit. Let's cut the chase. A learner set up the circuit shown below to determine the EMF and the internal resistance. So here's our circuit used to determine, and it says a learner obtained the following graph from the data of investigation. So the graph that we have here, it's a graph of current versus the potential difference. Do you see? It's a current in y-axis and the potential difference in the x-axis. So we are here, guys. This graph, we know it's a graph that has a slope that represents the internal resistance. But now, since the y-axis is the current and the x-axis is the potential difference, it's not going to be just the internal resistance, it's going to be 1 over internal resistance, because in the normal graph that we normally have is the potential difference and the current there, and it's like that. The gradient here, it's negative r, but now if you swap the two around, it's going to be 1 over r, right? It's an inverse of the and then okay, let's answer the question. 8.1.1. What does the graph represent? It represents the negative 1 over r, or inverse of internal resistance, right? That's what it represents, this graph. Determine from the graph the EMF of the battery. The EMF of the battery is the maximum potential difference here, which is, it's that one. So it's going to be what? 3 volts, right? It says determine the internal or lost volt, which is the V internal, if the current of the circuit is equal to 0.4. So the total current of the circuit is 0.4 amperes without the calculations, right? So what are we going to, that means we're going to take the value from the graph. The current of 0.4, here's the current of 0.4. It corresponds with the potential difference of 0.1. So the answer there, it is so the current, the V internal, right? This is the V internal. If the current there, it's that, so they want the V internal. So guys, here this is going to be our V, this is going to be our V external, this value, this is the V external. So the question, it wants us to calculate the V internal. So the V internal, it's a V internal is equal to EMF minus the V external. So we got the V external from this current of the circuit. So we're going to say the EMF, which is 3, this is the EMF, which is 3, minus the V external, which is 1, which is going to be 2 volts. So the V internal is or the V lost is equal to 2 volts. I hope it makes sense, guys. Hope I didn't fumble on that one. Calculate the internal resistance of the battery. The internal resistance of the battery, there are many ways to do it. You can use the gradient. Okay, let me start with the easy one before the gradient. So it's 8.1.4. 8.1.4. The easier one I can say V internal. We already have the V internal is equal to I times R. So our V internal is what? Is 2, and the total current of the circuit, we are told it's 0.4, and then we are looking for the internal resistance. So if you divide by 0.4 both sides, it's going to be 5 ohms. Alternatively, we can use the gradient. So the gradient here is negative 1 over r, that's our gradient, I mentioned that, is equal to change in I, which is our y, it's I, over change in V. change in I over change in V, which is going to be 1 over R, negative 1 over R. So we'll take any 2 points. I'm going to take this point. This point, it's going to be 3 is 2 into 0, and I'll take the last point there. You can take any point. So it's going to be 0 into 6. So I'm going to take, this is the final, it's a I final, which is going to be 0 minus what? 6 divide by 3 minus 0. It's 3 minus 0, and then when we calculate that, you punch that in the calculator, it's going to be negative 0.2, which is it's 1 over R, and then you just put, okay, you divide by the negative first, both sides. It's going to be 0.2, like that. You are looking for R, not the gradient. It says it want R here, not the gradient. So you do the inverse of that, it will give you R. R is equal to 5 ohms, right? Hope that makes sense. Now let's go to 8.2, the other part of the question. It says a circuit consists of a battery with an EMF of 30, we're given there. An internal resistance is 1 ohms, we're given the internal resistance there. A motor M, there's a motor here. A motor M with a resistance of 6 ohms. A variable resistor, which is a rheostat, can be a set at a different value R. So we have a variable resistance there, variable resistor, but we do not know the resistance of that. It's just given R there. The variable resistor is a resistor that you can change, guys, just like this one. It's the same. It's the one that you can change, you decrease or increase, right? Is connected in parallel to 5 ohm resistor. So this variable resistor is connected in parallel with this one, and the switch S are connected as shown in the diagram below. There's a switch here in this line of the 5 ohm resistor. The resistance and the ammeter of the conducting wire can be ignored, right? Looking at the circuit there, the current comes from this side and then it passes there. That means it's the total current that passes there. The 6 ohm passes the total current, and then it splits there. Let's say for if this switch is closed, so they'll split, and then there will be another one that goes that way, the split, and then they combine again. They give us the total. So this ammeter reading, it gives us the total, right? So if this switch is open, the current will come from here and it will pass there and go there. So there won't be a current that is going in this side because this switch is what is open, right? Now state Ohm's law, guys. I'm not gonna waste time on that. Switch S is initially open. Now they said this switch is what is open. Now they said switch S is initially open. The reading on an ammeter is 3A, so it's 3A. So as I've mentioned before, the current will go only this side, right? So the only resistors that are effective is this and that, right? Only the two, and they are in series, right? What is the reading on V1? Where is V1? V1 is connected here. So since this resistance is not effective, there's no current that is moving there, so the voltage that is needed there is going to be what? 0. It's 0 volts. Calculate the reading on V2. Where is V2? That one. So when there's a current in the circuit, that means the EMF that was 30 dropped. So that means this reading now is no longer reading the EMF, is reading the V external. So this is the V external that they want. It's V load. So how are we going to go about that? It's 8.2.3, right? What are we going to do about that? Getting the V external. So what I'm going to do, I'm going to use the formula that says EMF is equal to I R times R. Now what I want the V external. So the formula, it will be V external is equal to EMF minus the V internal. So the V external is the difference between the EMF and the V internal. So the V external is the one that I want. The EMF I have. So the V internal here, it's going to be I times R. Are we having that? We have that. The total current we have, it's 3, and the internal resistance, it's 1. So it's going to be easy for that. So it's going to be a 30, which is the EMF minus, and the current is what? Is 3, and then we times by the internal resistance, which is times 1, which is, it's 30 minus 3 is equal to 27. Right? That's that, right? So it's 30 volts. So there's so many ways to do that, guys. So we're done with the V external, which is, it's what? It's V2. V2, it's V external, right? Now 8.2.4, it says calculate the resistance at which the variable resistor R is set. Now this resistor, it has a resistance. So while this is happening, it has a resistance. We want to know what is its resistance there, right? So the way we're going to do it, I'm going to use the external resistance, and the external resistance, it's only these two. So, and these are in series, so it's addition. So it's going to be R, the resistance of the motor plus the resistance of the rheostat. But we do not know the external resistance. The only resistance we know is the resistance of the motor. So I'm going to find this first. So finding that, I'm going to use this. E is equal to EMF is equal to I, R external plus the R. So I'm going to use that. The EMF is 30, and the current is what? Is 3, and the R external is the one that I want, and the R internal is 1. So I divide by 3 there, it's going to be 10 R plus 1, and then I take that. R is going to be 10 minus 1 is equal to 9 ohms. So the R external is 9 ohms. Then I go back to that, so it's going to be R external is equal to resistance of the motor plus the resistance of the rheostat. So it's 9, and the resistance of the motor is 6 plus resistance of the rheostat. So the resistance of the rheostat is going to be 9 minus 6 is equal to 3 ohms. Done. With that, so many ways you can do that, guys. I thought that's the easiest. Now the last question, it says the switch is now closed. So this switch is now closed. This resistor is now effective, and this one is effective. So the parallel and the series are now effective. The series is parallel. So now it says, how does this change, which is this change of involving this thing? So this resistor. So how does the change in V2? What is the V2? V2 is the what? Is the V external. So this question is asking the V external. Right, decrease or increase, or remains the same? So the answer here, guys, if you can see here, it was a series resistance when this switch was open. It was a series, which is the total resistance was what? High. So when you add the resistor in parallel, you are decreasing the total resistance. So decreasing the total resistance here, you are decreasing the V external. So the answer here is what? Is decrease. Why? The total resistance decreases. So if the total resistance decreases, that means the total current increases. So if the total current increases, the V internal increases, right? While the internal resistance is what? Is constant. All the time the internal resistance and the EMF are constant, and therefore the V external is going to what? Decrease. It decreases. Why? The V external Because from this formula that says V external is equal to EMF minus the V what? Internal. So if you're looking here, the V internal, what is happening is increasing, and the V external, it has to decrease to maintain the constant EMF there. So you need to state that the EMF is what? Is constant. So what is important in this question is to answer by decrease or increase, or that's the answer. And then another thing that is important, you need to state what is happening to the total resistance here. So the total resistance, as you mentioned, that it is going to decrease. So that's the mark there. That's important. And then you state what is going to happen to the current. What is going to happen to the current? In fact, these two things, they have one mark, any of the two, and then you get the mark for this, right? And then the last mark, it's for stating that the EMF is going to be what? Constant. Right? It's very important, guys. Even stating that it's going to be constant, it's very important. I hope this makes sense, guys. Cheers, bye.